morning. Today we will discuss about current in a conductor. It is a 12th CBSE second PU also. It will come this topic will come in 12th CBSE. Current in a conductor or motion of electric current, motion of current in a conductor and its equations and major definitions. Very important concept for exam point of view. Current electricity in second PU, one topic is the current electricity or electric current. Third topic in part second textbook, highest weightage in that second PU when compared to all the topics. Second highest weightage goes to semiconductor. Exam purpose ga highest weightage ಅದೇ topic ಇಂದ ಬರೋದು. Many derivations and important definitions are there. Today I will discuss about this mainly. Actually I am requesting to share and subscribe. Those who are willing to support poor and rural students, I'm mainly doing this for poor and rural students only. ಆ್ಯಕ್ಚುಲಿ ನಾನು ಎಲ್ಲಿ ವರ್ಕ್ ಮಾಡಿದ್ನೋ ಅಲ್ಲೆಲ್ಲ ನಾನು ಕ್ಲಾಸ್ ರೂಮಲ್ಲಿ ಅನೌನ್ಸ್ ಮಾಡ್ಕೊಂಬಂದಿರೋ ಇಷ್ಟೊತ್ತಿಗೆ ಸಬ್ಸ್ಕ್ರೈಬರ್ಸು ದಾಟಿರೋದು 500. ನನಗೆ ಐ ಆಮ್ ಅನೇಬಲ್ ಟು ಕಮ್ ಲೈವ್ ಇನ್ ಯೂಟ್ಯೂಬ್ ಕ್ಲಾಸ್. ಲೈವ್ ಬರೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ, ಅಲ್ಲಿವರೆಗೂ ರೆಕಾರ್ಡ್ ಮಾಡಿ ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. ಸೊ ಟುಡೇ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ಆ್ಯಂಡ್ JEE ಮತ್ತು CET ಕ್ಲಾಸಸ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಈ ಸೆಕೆಂಡ್ PU ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿಬಿಟ್ಟು 12th CBSE ಏನೇನಿದೆಯೋ CET ಮತ್ತು JEE ಕಾನ್ಸೆಪ್ಟ್ನ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. ಅದಕ್ಕೆ ಸ್ಲೈಡ್ ಇಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಕಂಪ್ಯೂಟರ್ ಕ್ಲಾಸ್ ಹಾಕ್ತೀನಿ, ಸ್ಲೈಡ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಈ ಸೈಡ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ ಡೌಟ್ಸು. ಆ್ಯಂಡ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಆಲ್ಸೋ ಇನ್ ಫ್ಯೂಚರ್ ಐ ವಿಲ್ ಟೀಚ್ ಮ್ಯಾಥ್ಸ್ ಆಲ್ಸೋ, ಮೇನ್ಲಿ ಸೆಕೆಂಡ್ PU ಐ ವಿಲ್ ಹ್ಯಾಂಡಲ್. ಫಸ್ಟ್ PU ಎಲ್ಲ ಬೇಡ. Physics both first PU and second PU along with IIT JEE NEET. Mathematics mainly 12th class 12th CBSE PU I will concentrate. Today I will discuss about the motion of electric current in a conductor. Current in a conductor. Current in a conductor. So we know that already the definition for electric current. ಕರೆಂಟ್ ಸ್ವಲ್ಪ ಈಗ ಮೇಲ್ಗಡೆ ಬರೆಯೋದು ಕಷ್ಟ ಆಗುತ್ತೆ, ನನಗೆ ಅದೇ ರೂಢಿ ಇಲ್ಲ. ಆಲ್ಮೋಸ್ಟ್ ಬೋರ್ಡ್ ಕೆಳಗಡೆನೇ ಕಟ್ಟಿದ್ದೀನಿ. ಕರೆಂಟ್ ಇನ್ ಎ ಕಂಡಕ್ಟರ್ heading. So we know that already what is meant by current. It is electric current. So from this equation it is actually, we will say, the flow of electrical charges. The flow of electrical charges are I is equal to Q by T. I is equal to dQ divided by dt. Also we will use the flow of electrical charges. The time rate of flow of it is the time rate of flow of electrical charges. Electrons denoted by basically in general E minus. Majority charge carriers in electric current or electrons, minority are holes. Majority and minority charge carriers, like that it will come. The flow of charges, the flow of electrical charges, positive and negative. One more is neutral will come. Wire, 3 wires will be there. ಓಮಲ್ಲಿ ಇದನ್ನು ಮಾಡಬೇಕಾದ್ರೆ ವೈರಿಂಗ್ ಮಾಡಬೇಕಾದ್ರೆ 3 ವೈರ್ಸ್ ಇರುತ್ತೆ, ಗ್ರೀನ್, ಬ್ಲ್ಯಾಕ್ ಆ್ಯಂಡ್ ರೆಡ್ ಅಂತ. ಇನ್ 10th CBSE ಅದು ತುಂಬ ಚೆನ್ನಾಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದಾರೆ ಫ್ಯೂಸಸ್ ಬಗ್ಗೆ, ಹೌ ದಟ್ ಫ್ಯೂಸ್ ವಿಲ್ ವರ್ಕ್, ಗ್ರೌಂಡು, ಅರ್ಥಿಂಗ್ ವೈರು, ಪಾಸಿಟಿವ್, ನೆಗೆಟಿವ್, ಗ್ರೀನು, ಅದೆಲ್ಲ ಬ್ಲ್ಯಾಕ್ ವೈರು, ಮೂರು ಕಲರ್, ಅದು ಏನಕ್ಕೆ ವೈಶಿಷ್ಟ್ಯತೆ ಇದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು 10th CBSE ಇದೆ. ಓಕೆ, ಲೀವ್ ಇಟ್. ದಿಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು 12th ಕ್ಲಾಸ್ second PU. Current in a conductor. How electric current will travel? I will consider one conductor. I will write one small diagram. I will consider one conductor. So I will connect this conductor to a battery power supply along with a plug key. The longer terminal is positive. The longer terminal is positive. Where is that reading? The longer term is positive. The shorter term is negative. So the current will always emerges or diverges from the positive terminal. So inside electrons will travel. There are many electrons will travel inside. Many electrons will travel like this. They will travel inside. So electric current in a conductor, and what are the equations are there? Today we will derive this equation. I is equal to NAE VD. So let small letter L is the length of this conductor, and area of cross section is capital A. Area of cross section is capital A. In relaxation time, or during the time of explaining the definition relaxation time, I will explain how the electron will travel. So the electrons will collide with the walls. It will go on collide here. It will come on collide here. Again, it will collide. Go on collide here. Again, it will collide here. Zigzag motion, and the electrons or electric current will travel inside the conductor. Zigzag means almost a Z shape, not exactly Z shape like this. They will collide, they will go and collide somewhere, they will go collide and somewhere, they will go collide somewhere, they will go with the walls. Where they will collide? To the walls of the conductor. To the walls of the conductor they will collide. So there actually the electrons will exhibit, or they will perform many collisions inside the conductor. So what will happen due to that collisions? What will happen to the electrons? The electrons will gains the velocity. The speed of the electrons will going on increases after making successive collisions. So initially it will go on. It will come here. It will go and collide somewhere here. It will gain some velocity. It will go and collide here. Again it will gain some velocity. It will go and collide here. It will gain velocity. It will collide here like this, like this. It will go out of the conductor. Here the normal could be like this. It will go out of the conductor. So like this, by making many number of collisions, the electrons will gain the velocity or they gain the speed. There is difference between speed and velocity. Both are not same. Speed here actually there is no particular direction. There is no particular direction. Current is a scalar. Even speed is also a scalar, having only magnitude, no particular direction. ಇಂಥದೇ ಡೈರೆಕ್ಷನಲ್ಲಿ ಹೋಗಬೇಕು ಅಂತ ಕರೆಂಟ್ಗೆ ಇಲ್ಲ. ನಾವು ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ವೈರಿಂಗ್ ಮಾಡ್ತೀವೋ ಆ ಡೈರೆಕ್ಷನಲ್ಲಿ ದ ಕರೆಂಟ್ ವಿಲ್ ಫ್ಲೋ. ಸೊ ನೋ ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್. So it will go and collide somewhere, and it will travel in the zigzag motion, and it will gain the velocity, and it will go out of the conductor. So like this the current here travel inside the conductor. So today we will derive this equation I is equal to NAEVT. Before that, I is equal to Q by T. What is the SI unit of this electric current? So the SI unit of this electric current is ampere. They will ask for 1 marks question. Write the SI unit for electric current. You can write down like this: ampere. The condition there actually the system of international. One condition is there. The first letter should be small letter A only. If you write like this ampere, they will not give marks. They will give, but the weightage is 0. The weightage is 0. It doesn't mean ampere. Caps lock should not come the first letter, or just you can denote cap letter A. The symbol how small letter cap letter A. 2 ampere current, 3 ampere current flows through a conductor in 1 second or 0.2 second like that. So the unit is ampere. So the definition of 1 ampere, previously one class alla ಹೇಳಿದ್ದೆ. ಈ 12th CBSE ಗೆ many definitions are there like this: 1 volt, 1 ampere, 1 ohm, like this 1 volt. Many definitions are there. How to define this 1 ampere? I will select some conditions. If Q is equal to 1 coulomb, and time is equal to 1 second, then substitute in that equation. I is equal to Q divided by T, that is equal to 1 coulomb divided by 1 second, that is equal to 1 coulomb per second, that is equal to 1 ampere. If 1 coulomb of charge flows through any surface in 1 second, then that current is said to be 1 ampere. That current is called as 1 ampere. So 1 ampere means what it is actually? It is nothing but current only. When? What are the conditions? 1 ampere is the current. When 1 coulomb of charge flows through any surface of the conductor in 1 second. That is 1 ampere. So this equation is very important. SI unit is very important, and this 1 ampere definition is very important. How the current will travel? Why it will make collisions? Because of collisions, what will happen to the speed of the electrons? Understood? What is the how it will in zigzag motion it will travel? That is very important. And here SI of electric current is very important, ampere. And this node, what is that? You should mind that while writing the full form of the word, this first letter should be small letter, ampere. Ampere. It is actually one of the scientists' name. He introduced the concept of electric current. So this is the current in a conductor and how it will travel. So next I will derive that equation I is equal to NaEVD. I will just keep that diagram how this equation I is equal to NaEVD. How that equation came, I will just derive that equation. For 2 marks or 3 marks, they will ask this derivation. Maximum for 3 marks. But 2 marks they will it is enough, not that much of big derivation. So you can start from I will derive this equation, current in a conductor. So we know that I is equal to Q divided by T. Further, from the quantization of charge, Q is equal to NEE. 3 basic fundamental properties are there. From that second property, charge is quantized, charge is conserved, and charges are additive in nature. Like that, 3 charge properties are there. We know that Q is equal to N into E. How much charge is occupied by this conductor? What is the conductor volume? Volume of this conductor. How we will calculate volume? In generally, area into length. This much of length, this much of area. Consider a conductor of length L and area of cross section capital A. So entire this conductor, throughout the volume, the electrons will flow. Therefore, you can multiply A and L. Total charge. How to get the total charge? You can just multiply for this N into E. You can multiply A into L. It is possible to write down NaEL. You can rearrange the terms like this. Further, you can substitute this value of Q here in this equation. Here you can substitute. In exam, you can write down, instead of writing the words, substitute the value of charge Q in this equation. You can show the R mark also, no problem, nothing will happen. Substitute here, then I is equal to the equation will become, in place of Q, you can write down this equation NaEL divided by T. Now further you can rearrange this term. I will rearrange this term NaE. You can keep it like that. L divided by T. What is this? L divided by T. How much distance will travel by how much time? Distance traveled divided by time taken. What is that? It is velocity. But here drift velocity in this electric current, I will explain that definition. The electrons will drift towards the positive potential under the effect of again in a direction against the electric field. Later I will explain. This L divided by T is velocity. In generally we will take it as here in current electricity Vd. So in particularly, distance traveled, how much distance they will travel, how much length this conductor, how much length it is there, how much distance it will travel in how much time. So therefore NaEVD. So therefore the final equation will become I is equal to NaEVD. This is the expression for current in a conductor. So I will explain here Ohm's law. The same diagram I will explain Ohm's law. Many of our lecturers, as I have observed, even many of the senior lecturers are doing mistakes in this Ohm's law. They will write what they will write usually. I'm just checking what is recording or not. They will write V is directly proportional to I. Remove this proportionality constant, put R. V is equal to IR. This is the Ohm's law. Like that they are telling till today, many of the senior lecturers and even some HODs also. This is not actually correct. This is not how you people will are going to agree this in future. Even many of my students did MSc Physics. Almost 52 of my students doing math completed MSc in different subjects. Physics only 14 students completed till now. Those who are there, my students, Ohm's law, please don't say like this for students. What is the Ohm's law actually? Where is the tester? What is Ohm's law? The electric current, the current flowing through the conductor. As I take this circuit, switch on this is a plug key. Plug key acts like a switch. So close the plug key, then electric current will flow through the conductor. Understood? So it will produce what will happen when electric current flows through the conductor? It will produce a potential difference V across the conductor. So from I will write here space is not there. I can just I will erase this L. I will take it as a V. What is Ohm's law statement? What is Ohm's law statement? The electric current flowing through any conductor is directly proportional to the potential difference provided temperature and other physical conditions remains constant. That is the important condition. Provided means conditions. Temperature and other physical conditions remains constant. So that is the Ohm's law statement. I is directly proportional to V, potential difference. Current flow ಆದರೆ ಮಾತ್ರ potential difference generate ಆಗುತ್ತೆ. Current flow ಆದರೆ ಮಾತ್ರ potential difference generate ಆಗುತ್ತೆ. ಸ್ಟಾರ್ಟಿಂಗ್ ನೀವು many of the lecturers doing V is directly proportional to I ಅಂತ ಬರ್ಕೊಂಡ್ಬಿಟ್ಟು ಅಲ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ರಿಮೂವ್ ಮಾಡಿ ಆರ್ ಹಾಕಿ ಓಮ್ಸ್ ಲಾ ಬಂತು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಾ. ದಟ್ ಈಸ್ ನಾಟ್ ಗುಡ್ ಆಕ್ಚುಲಿ. ದ ಎಕ್ಸಾಕ್ಟ್ ಓಮ್ಸ್ ಲಾ ಫಾರ್ಮ್ ಈಸ್, see what is the statement, what is there in the statement. This is actually the basic and easy law, that only many of the lecturers doing mistake till now. The current flowing through a conductor, that is the statement is there. You people are directly writing V is directly proportional to I. Where is there in that any textbook? You can show me. What is Ohm's law statement? It is there like this. According to as per you people are writing, potential difference is directly proportional to electric current provided temperature and other physical conditions remains constant on the idea Ohm's law statement. What is Ohm's potential difference is directly proportional to electric current on the idea. A potential difference in the electric current generate agala. From current, electric potential difference is generating. Understood? If current flows, then only potential difference will generate across the ends of the conductor. The statement electric current is directly proportional to the potential difference, like that it is there. Understood? Then how to get this Ohm's law? So you can see the electric current flows through the conductor is directly proportional to the potential difference provided temperature and other physical conditions remains constant. Remove this proportional constant and put this sigma. What is that sigma? It is conductance. So here you can write I is equal to sigma into V, but sigma is equal to 1 divided by R. This resistance and conductance are inversely proportional. Resistance and conductance are inversely proportional. Understood? Now we can write here I is equal to sigma means 1 divided by R into V. Now send this R, it is there in R is there in the denominator, it will go this side. Now IR is equal to V, or V is equal to, you can even both V is equal to IR because equals is there. Here product term is there. ನೀವು 2 is equal to 3 ಅಂತ ಬರೋದ್ರು ಒಂದೇ, 3 is equal to 2 ಅಂತ ಬರೋದ್ರು ಒಂದೇ, RI ಅಂತ ಬರೋದ್ರು ಒಂದೇ, IR ಅಂತ ಬರೋದ್ರು ಒಂದೇ. Nothing changes because in the middle multiplication is there and equal symbol is there. The value will not change. Therefore V is equal to IR is equal to V, or V is equal to IR. V is equal to IR. This is actually Ohm's law. This is Ohm's law. Please do like this Ohm's law. Don't do like that. V is directly proportional to I. Remove proportional, put R. Proportional remove ಮಾಡಿ R ಹಾಕೊಳ್ಳಿ, Ohm's law ಬಂತು. Please, I am requesting even for all my senior lecturers and for HODs and upcoming little physicians and my students or anyone is there. So this is Ohm's law actually. Now, So very important concept, this derivation equation I is equal to NaEVd, current in a conductor equation, and this Ohm's law, understood. Next, this is a original form. Another form is there for that Ohm's law. From this equation only we shall derive that. From this equation I is equal to NaEVt. Before going to that is called as macroscopic form. Before going to that I will define this resistance and 1 ohm definition. How to define this? What is basically what is resistance actually? What is resistance? See, each and every conductor, each and every material offers or creates opposition to the direction of flow of electric current. Electric current will come, ಅಲ್ಲಿ ಹೈ ಕಾಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಬಂದಾಗ ಡ್ಯಾಮೇಜ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಎನಿ ಕಂಡಕ್ಟರ್ ಡಿವೈಸ್. ಸೊ ದೇರ್ ಫೋರ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಮೆಟೀರಿಯಲ್ ಕಂಡಕ್ಟರ್ ಇಟ್ ಸೆಲ್ಫ್ ರೆಸಿಸ್ಟ್ಸ್ ಆರ್ ಕ್ರಿಯೇಟ್ಸ್ ಅಪೋಸಿಷನ್ ರೆಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ ಅಪೋಸಿಷನ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ಗೆ. ದಟ್ ಅಪೋಸಿಷನ್ ಆಫರ್ಡ್ ಬೈ ದ ಕಂಡಕ್ಟರ್ ಇಟ್ ಸೆಲ್ಫ್, the opposition offered by the conductor itself, that is called as resistance of the conductor. Define resistance ಅಂತ 1 marks ಗೆ ಡಿಫರೆಂಟ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ. ಫಾರ್ 1 marks define resistance. On that time you don't write it is the ratio of V by I, don't write like that. From that equation it is possible to write down R is equal to V divided by I. Define resistance ಅಂತ ಕೇಳಿದ್ರೆ it is the ratio of potential difference to electric current ಅಂತ ಬರೆದ್ರೆ they will award 0 marks. They will give 0 marks. Okay. Definition is different. What is that definition? The opposition offered by the conductor to the direction of flow of electric current. Yake opposition create? What is the necessity of creating opposition? Means to damage, to escape or prevent the damage. The material itself offers electrical resistance to the electric current, that is called as resistance. SI unit is OHM, ohm. The symbol is like this. Now define 1 ohm. Already ಒಂದು ಯಾವುದೋ ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಮಾಡಿದ್ದೆ ಇದನ್ನೆಲ್ಲ, ಬಟ್ ಬೇಗ ಐ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ದ ಸ್ಪೀಡ್ ಬಿಕಾಸ್ ಐ ಶುಡ್ ಗೋ ಟು ದಟ್ ಈಕ್ವೇಷನ್. 1 ohm ನ ಯಾವ ಥರ ಡಿಫೈನ್ ಮಾಡಬೇಕು? ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಸಮ್ ಕಂಡೀಷನ್ಸ್. ಇಫ್ V is equal to 1 volt and I is equal to 1 ampere, then substitute these two values in this equation. 1 volt divided by 1 ampere, that is equal to 1 volt per ampere, that is equal to 1 ohm. Then what is this 1 ohm? I will increase the speed because already I did this one in one class. 1 ohm is the resistance of the conductor when 1 ampere current flows through a conductor to produce a potential difference of 1 volt. ಅಂದ್ರೆ ಈ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ 1 ampere ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆದರೆ ಆ 1 ampere ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ 1 ವೋಲ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದು ಅಂತ ರೆಸಿಸ್ಟೆನ್ಸ್ 1 ohm ಆಗಿರುತ್ತೆ. Our resistance 1 ohm ಆಗಿರುತ್ತೆ. 1 ohm is the resistance of the conductor when 1 ampere electric current flows through any conductor to produce a potential difference of 1 volt. Now I will derive that this is original form. Macroscopic form is there. J is equal to sigma E. For 3 marks, many times they have asked this equation. Derive J is equal to sigma E. Or 2 marks, for 2 marks they will ask. Maximum for 3 marks, minimum for 2 marks they will ask. What is this J? Current density actually. J means, that is also one of the very important definition. Here 4 important definitions are there. 4 important definitions. Current density, drift velocity, relaxation time and mobility. For these, out of these 4 important definitions, one definitely will come. Many times they have asked for 2 marks definition along with SI unit for 2 marks, or only definition for 1 marks. How to derive this in macroscopic form? J is equal to sigma into E. So I can take from that equation I is equal to NaEVd. ಇದು ಆಕ್ಚುಲಿ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಆದ್ಮೇಲೆ ಮಾಡಬೇಕಾಯಿತು, ಇರಲಿ, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಆದಮೇಲೆ ಮಾಡಬೇಕಾಯಿತು, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಡೆರಿವೇಷನ್ ಆದಮೇಲೆ, ಬಟ್ ಐ ವಿಲ್ ಡೂ ಇಯರ್ ಓನ್ಲಿ. Okay, because related to Ohm's law I will erase this one, that's why. So we know that I is equal to NaEVd. Take this, send this capital letter A to LHS, it will become I divided by A, that is equal to N into E. This value of drift velocity equation no small letter e capital E divided by m into relaxation time, where small letter e is charge of electron. This is electric field. Capital E is electric field. M is mass of the electron. Tau is relaxation time. So I can write here this Vd value, substitute here. Substitute Vd value from this equation. Then it will become I is equal to N. A already sent it to LHS. It already gone to LHS. N into small letter e. Vd means small letter e, capital E divided by m into relaxation time. Now this I by A is written as J, where J is current density. What is this J? J is current density. What is current density? And write down its SI unit. For 2 marks it will come. Understood? For 2 marks question. J is current density. So SI unit, what is SI unit? I will write here only. For electric current, ampere, it is area divided by, for area, meter square. So ampere per meter square is the SI unit for this current density. Definition, you can say current per unit area of cross section. Current per unit area of cross section, or the ratio of current to area of cross section is called as current density. So you can simplify this equation. Small letter e, capital E divided by m into relaxation time. So I by A, already J we have written. So it is n into small letter e into small letter e square into into relaxation time. I am making group also. Here only I will make it as a group. Divided by m into capital E. So this, what is there inside the bracket? N e square tau divided by m. This is called as conductivity. Understood? Or conductance, sigma. Therefore the equation will become J is equal to sigma into E. This equation is called as macroscopic form of, another form of Ohm's law, or macroscopic form of Ohm's law. Understood? This is original form, microscopic, or V is equal to IR, it will call another original form. See, J is equal to sigma into E, where sigma is equal to what? Sigma is N E square tau divided by M. This is called as conductivity. Is conductivity or conductance? Is conductivity of a material of conductor. Conductivity of a material of conductor. Okay. See, J is equal to sigma E. For only 4 steps, 1, 2, 3, 4. Maximum for 3 or 2 marks they will ask. Take I is equal to NEVD, substitute VD value here. Simplify E square, make it as a group. This I by A called as J, current density, into capital E is there here. J is equal to sigma into E. What is there inside the bracket? Call it as a J. So J is equal to N E square tau divided by M. Here one important definition. What is current density, and write down its SI unit. What is current density and write down its SI unit. Current density definition, current per unit area of cross section. We can write down current per unit area of cross section is called current density, denoted by the letter capital J. SI unit is ampere per meter square. SI unit ampere per meter square. So or else you can write down the ratio of electric current divided by the ratio of electric current to area of cross section. Understood? I will erase this. Next one important derivation is the drift velocity. I will derive that equation. Maximum 40 minutes it will take this recorded. After that, if I recorded more than 45 minutes, it is unable to upload in the YouTube. Not possible to upload. Understood? Or for drift velocity, this diagram is not required. I will erase this one also. Drift velocity derivation. It is very important for 3 marks. Definitely, many times already they have asked for 3 marks. Along with the definition, 5 marks they will ask for 5 marks also. So drift velocity derivation. Drift velocity denoted by Vd, where the suffix d stands for drift. What is this drift? Drift means move. In generally, drift or drift avadu. What is meant by drift? Move. What is the definition? The velocity, within some amount of velocity, the electrons drift towards the positive potential under the effect of applied electric field in a direction opposite to the direction of electric current. So, drift velocity means the velocity within which the electrons drift towards the positive potential under the effect of applied electric field. How it will drift in the direction against to the electric field? Electric field ki against agi electrons drift agutte. See, I have written one diagram. So like this, the conductor. So this is positive, this is negative. The electric field is our diverges, emerges, diverges from positive, converges to negative. In negative, the inverse marks irutte. For negative, inverse. Understood? So for positive, outwards in this direction, electric field will be there in this direction. Positive, from positive going out, diverges, converges or terminates at negative. So electric field e direction is right. Electrons ಯಾವ direction ಅಲ್ಲಿ travel ಆಗುತ್ತೆ ಅದಕ್ಕೆ opposite direction ಅಲ್ಲಿ e directionally in this direction electrons will drift. So e will be in this direction but electrons will travel in this direction, in a direction opposite to the direction of applied electric field. The electrons will drift within some amount of velocity. A velocity x ಸಿಗುತ್ತೆ ಅವಕ್ಕೆ. How the velocity will get due to collisions. Due to collision suffered by an electron with the walls of the conductor. So I will derive the equation. We know that from the laws of motion V is equal to U plus AT from the laws of equation. Here I will take, here V means drift velocity Vd. Initially there will be 0, initial velocity 0, and time I will write it as a relaxation time. I will take it as a relaxation. A is acceleration. Once if the electron moved means they will accelerate. They will go to exit, they will collide, they will accelerate. They will get acceleration. For all the moving bodies, speed will be there, velocity will be there, acceleration will be there. Understood? So I will start from this equation for drift velocity to derive that equation. So V is equal to Vd. Here we will take V is equal to Vd. Substitute all these data to this equation. It will become Vd is equal to initial velocity 0 plus A into tau. Vd is equal to A into tau. Tau means relaxation time. So Vd is equal to A into tau. Understood? Call it as equation number 1. Further, we know that from Newton's second law, we know that F is equal to m into E, mass into acceleration. Therefore, acceleration is equal to simplify this equation. Acceleration is equal to F divided by m. Understood? Acceleration is equal to F divided by m. Further, we know that E is equal to F divided by Q. Cross multiply this equation. F is equal to Q into E. F is equal to Q means charge. What are the majority charge carriers here? Electrons. So I will write it as small letter e into capital letter E. I will substitute that F value here in this equation. Then acceleration becomes small letter e, capital letter E divided by m is there, because acceleration is equal to F divided by m. Small letter e, capital letter E divided by m. This is the value of acceleration. Further substitute this acceleration value in this equation number 1. Put this a value, substitute the value of, put a in equation number 1. Then drift velocity is equal to, drift velocity means a into relaxation time. The value of a is small letter e, capital letter E divided by m. Here tau is there, you can write down tau. So this is the expression for drift velocity. This is the expression for derivation for drift velocity. Vd is equal to small letter e, capital letter E divided by m into tau. Understood? Vd, drift velocity. So this is the derivation for drift velocity. So you can just take from the equation from Newton's laws of motion. 3 equations are there. From one equation, v is equal to u plus at. V means drift velocity, u means initial velocity, tau realization time, we will take it as tau. Substitute here a, v initial velocity is 0, vd is equal to a into tau. Newton's second law, F is equal to m into a. Simplify, a is equal to F divided by m. Further, electric field E is equal to F divided by Q. Cross multiply, F is equal to Q into E. Majority charge carriers are electrons. F is equal to E into capital letter E, small letter into capital letter E. Substitute here in the value of A. A will become like this much. Further substitute A value here, then drift velocity will come. Here many substitutions are there. So practice madadre barutte. So these are all basics actually, but for new students or for that CBSE 9 level 12th students, it will become quite tough. So now I will define 4 definitions. After that I will end off. I will stop this class. 4 important definitions. 4 important definitions are there. 4 important definitions. Understood? First one is current density capital letter J. Second one is already I told, drift velocity Vd. Third one is mobility of electron. Fourth one is relaxation time denoted by tau. Mobility capital M anta mention ಮಾಡಿದ್ದಾರೆ. ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ, in some of the text books it is there. mu also it is there. In some of the text book mu is there. I will define one by one along with SI unit. For 2 marks they will ask this question. Definition plus SI unit. So what is current density? Just now during the derivation of macroscopic law, macroscopic form of Ohm's law. So J is equal to I divided by A. Current per unit area of cross section. SI unit for electric current, it is ampere for area meter square. So ampere per meter square is the SI unit. Ampere per meter square is the SI unit. Next definition, drift velocity. Just now I told what is drift velocity. The velocity within which the electrons drift towards the positive potential under the effect of applied electric field. Ali we have applied some electric field. On the electric field apply ಮಾಡಿರ್ತೀವಿ. Electric field apply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, the electrons will will go to excited mode. They will drift, they will dance. ಅರ್ಥ ಆಯ್ತಾ? ಡ್ಯಾನ್ಸ್ DJ ಆಡ್ತಾರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಎಲ್ಲ ಡ್ಯಾನ್ಸ್ ಕುಣಿತಾರಲ್ಲ ಆ ಥರ they will what they will go to excited mode and they will drift. So the electrons, what is drift velocity? The electrons, the velocity within which, the velocity due to which the electrons drift towards the positive potential under the effect of applied electric field, that is called as drift velocity. SI unit is for all kinds of velocity, the SI unit is meter per second only. Don't write second square, it will become to acceleration. It will become acceleration. Mobility. What is mobility? Drift velocity divided by unit electric field. Drift velocity per unit electric field. The ratio of drift velocity to electric field is called as mobility. What is the SI unit? What is the SI unit for velocity? It is meter per second divided by. For electric field, 2 units are there. What SI units? One SI unit is Newton per coulomb. Another SI unit is volt per meter. I will select here. The second one is volt per meter. Here also meter is there. Here also meter is there. For simplification, it will become easy. Therefore, I have taken this SI unit volt per meter. Simplify this equation. The SI unit will come for mobility. Simplify this equation. So it is meter divided by second into, this will become ulta reciprocal because it is there in a denominator, into meter divided by volt, m into m square. So meter square per volt per second. Per volt per second is the SI unit. For mobility, SI unit is meter square per volt per second. Understood? You can say the definition: drift velocity per unit electric field. Relaxation time. What is relaxation time? Just now I told during the time of how the electrons will travel inside the conductor. During the time of traveling, what will happen? They will make n number of collisions. They will go and collide here, they will come and collide here, again they will go and collide here, they will come and collide here. So the time elapsed between two successive collisions, not alternative, successive. Successive means from this and this, not from this and this. Understood? From this collision and this collision, how much time will elapse? That is called as relaxation time. The time elapsed between two successive collisions suffered by an electron. The electrons will make collisions. The time elapsed between, elapsed means created. The time elapsed between two successive collisions suffered by an electron is called relaxation time. From these two collisions, or from these two collisions, or from these two collisions, not from this and this, or not from this and this. So that is the definition. For all kinds of times, the SI unit is second only. For all kinds of time, the SI unit is second only. So for relaxation time also, the SI unit is second denoted by S. Understood? These are the 4 important definitions. Out of these 4, definitely one question will come along with the SI unit. For 2 marks, they will along with the SI unit they will ask. Understood? For 2 marks. For 1 marks, only definition or separately definition or SI unit they will ask. Understood? Current density, drift velocity, mobility, and relaxation time. Current density means current per unit area of cross section, J is equal to I by A. Drift velocity, the velocity due to which the electrons drift towards the positive potential under the effect of applied electric field, that is called as drift velocity. Mobility, mobility means drift velocity per unit electric field. Drift velocity per unit electric field, VT by capital E, the ratio of drift velocity to electric field. Relaxation time, the time elapsed between two successive collisions suffered by an electron, that is called as relaxation time. So I will stop at here. 40 minutes is enough. So please share. Even I'm sharing everywhere in my Instagram, Facebook. Share and subscribe. Share and subscribe. I want some subscribers to come for live classes. Understood? YouTube live classes ಬರೋದಕ್ಕೆ. So that Ohm's law is very important. Many of the lecturers till today, very much experienced lecturers making that mistake. Don't write V is directly proportional to I. Remove proportional, put R. V is equal to IR. That is not the good one. The statement is I is directly proportional to V. Understood? That you can correct it, all the lecturers. even senior lecturers. Uh, Students also in future you can adopt it. In next class I will do about that specific resistance and this relation between conductance, resistance, conductivity, resistivity, and some one problem is there. Very important problem for 2 marks. What will happen to resistivity when its length doubled? Understood? Area, what will happen to area there? Twice or thrice or some problems I will do. And resistance, series and parallel combination. To get maximum amount of current, how the resistances should be connected, whether in series or parallel, I will discuss that. ಕರೆಂಟ್ ಜಾಸ್ತಿ ಬೇಕು ಅಂದರೆ ಜಾಸ್ತಿ ಕರೆಂಟ್ ಬೇಕು ಅಂದರೆ ಯಾವ ಥರ ಸೆಲ್ಸ್ನ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು ಸೀರೀಸ್ ಆಗ ಪ್ಯಾರಲಲ್ ಆಗ ದಟ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್. And related to fuses in 10th CBSE they have explained very well what is the work of a fuse, what it will do, grounding that three colors of the wire, green, black, white, ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಇನ್ ದ ಹೋಮ್ ಮನೆಯಲ್ಲಿ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ದಟ್ ಗ್ರೀನ್, ಬ್ಲ್ಯಾಕ್ ಆ್ಯಂಡ್ ರೆಡ್ ವೈರ್. ನೆಕ್ಸ್ಟ್ ರೆಡ್ ಈಸ್ ಪಾಸಿಟಿವ್, ದಟ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್. ಓಕೆ, ಟುಡೇ ಐ ವಿಲ್ ಸ್ಟಾಪ್ ಅಟ್ ಹಿಯರ್. ಥ್ಯಾಂಕ್ ಯು. Board is very important actually. The teacher and the one who the best teacher or lecturer should love the board.